This is R, this is side step, this is Vs, the current is I0, the voltage across load is V0, and the voltage across side step is Vt. Vs is equal to Vm is the maximum voltage sine omega t. The main thing is power electronics is waveform. So here I am draw all the waveform like supply voltage waveform, output voltage waveform, triggering waveform, output current waveform, and voltage across thyristor waveform. So I am start from supply voltage waveform. Then I am derive all the thing like output voltage, average output voltage, and output current. This is omega t. Supply voltage Vs is equal to Vm sin omega t. So this is a sine wave. Its peak value is Vm. So this voltage like this. I'm drawing it using a dark pen. This is Vm sin omega t. This is 0, this is pi, this is 2 pi, this is 3 pi, this is 4 pi. So this is Vm sin omega t, that is Vs. Here I am dotted all the key nodes like 0 position, pi position, 2 pi position, 3 pi position, like this. Now I am drawing here the triggering point. This is also triggering point is after alpha. So here I am dotted the triggering point line. This is half wave. So in this point there is a no trigger. Another trigger is this point, and this is alpha. This also be a alpha. This is alpha. Alpha is the triggering angle. This is also alpha. If it is full wave, then we also apply triggering in this position also, because there is only one thyristor and this conduct only one cycle. After this cycle will be not conducted because this thyristor will be in the reverse bias. So this is the triggering. This is the triggering pulse. This is Ig, that is triggering pulse. Now the output voltage waveform. Very interesting waveform. In my class, I am already discussed the different Turner method of thyristor. So just dotted. So after this position, the voltage will be present. So the voltage waveform is like this in positive half cycle. In negative half cycle, there is no output voltage because this is in reverse bias. So this voltage is like this. After in this position, if there is a 0 degree triggering angle rather than alpha, then triggering will be occur, but this alpha position is off position because after alpha position triggering will be happened. So this is the output voltage waveform. This is V0. Now I0. I0 is same like V0 because in resistive circuit there is no phase difference between voltage and current. So I0 also like same. I0 is also same. This is I0 load current and this value is Vm by this is Vm. This peak value is Vm. Suppose we can plot the peak value, then this is the Vm. This is Vm. This is also this Vm sin omega t, and this is Vm by R. R is the this resistance. This is Vm by R, the magnitude. Now the voltage across this thyristor is the last waveform voltage across this thyristor. That is Vt. When triggering is not done, after alpha triggering will be happen, the before alpha no current will flow through this resistance or this load, so there must be total voltage across thyristor. So it happened like this. This is a waveform of initial sine wave. So first there is a this voltage because there is a no triggering angle. After triggering thyristor will conduct. That means all current flowing through this thyristor, there is a no voltage, so voltage will fall to 0. After positive half cycle, this cycle is reverse bias, so all the reverse voltage across this thyristor, so this like this 0 position, and after 0 position there is a no conduction because alpha here is the conduction point, so this voltage also occurred, so this is no voltage. So this is the voltage across thyristor. Now if we apply RL load, then the scenarios differ. So RL load, I am writing here RL load. The circuit is same. This is Vs is equal to Vm sin omega t. One thing I missed, that is the average value of the output voltage and current. So in sine wave, the average value V0 is equal to integration 1 by 2 pi integration of 0 to pi Vs, that's equal to 1 by 2 pi integration of 0 to pi Vm, this is g omega t, Vm sine omega t d of omega t. Now I can separate 0 to pi, 0 to alpha, Vm sine omega t d of omega t plus alpha to pi Vm sine omega t d of omega t. Vm sine omega t in the limit 0 to alpha, that is this position. So this is 0. So I can write this value is 0. So average value will be 1 by 2 pi integration of alpha to pi Vm sine omega t d of omega t. So sine omega t integration is minus of cos omega t. So Vm by 2 pi minus of cos omega t alpha pi. So I can write Vm by 2 pi, first of all minus cos omega t. So upper limit minus lower limit. So minus of cos pi minus minus of cos alpha. So minus of cos pi minus minus of cos alpha. So we can write Vm by 2 pi minus of cos alpha means minus 1. So minus of cos alpha 1 is equal to 1 plus 1 plus cos alpha. This is the equation of output voltage waveform. And output current waveform, average voltage current waveform, Vm is equal to V0 by R, that is Vm by 2 pi R 1 plus cos alpha. Now I am going